Hello. In this video, I want to go ahead and start looking at graphing logarithms. So first of all, I want to graph y equals 2 to the x and y equals log base 2 of x on the grid below, and I want to complete this table. So the functions that we're looking at are y equals 2 to the x and y equals log base 2 of x. So here's the thing. For the 3 key points here, I can actually do the first one. Let's do the first one in the y equals 2 to the x in green. So when we're doing the 3 key points, they begin with -1, 0, 1, with the 1 right there. The y value is what changes here and here. The question is what is it? Well, the base of the exponential is 2, and this negative means I take the reciprocal, and the reciprocal is a half. This 1 means I keep the base, so in this case the base is 2. And those are the 3 key points. Also, because this is just the parent function, the asymptote here is going to become y equals 0. Notice that this is a horizontal asymptote. Now for the intercept, this is specifically a y-intercept of 0, 1. Because it's always that middle one right there. Good. And the domain range is -infinity to infinity and 0 to infinity. This is nothing new. What I'm going to do now is I'm going to look at y equals log base 2 of x, which I'm going to do in blue. Now, because the logarithm is the inverse of the exponential function, that means that the 3 key points are flipped. The x's from the previous one are the new y's, and the y's from the previous one are the new x's. So the y's are the ones we fill out first as -1, 0, 1 with a 1 right there. And this -1 means I flip the base, and the base is 2, so the reciprocal is a half. And this 1 means I keep the base, and the base is 2. So these will be the 3 key points for this logarithmic function. Also, the asymptote is no longer horizontal because this y becomes an x. So x equals 0 is the horizontal asymptote, in this case, vertical asymptote. So vertical asymptotes are wherever the argument is equal to 0. Notice that the domain is where the argument is greater than 0. So the vertical asymptote is where the argument is equal to 0. Good deal. And this time when we look at that middle, coordinate here, 1, 0, that's actually an x-intercept. And that makes sense because if you have a y-intercept, the y becomes an x. So we have an x-intercept of 1, 0. And the domain and range are flipped from the y equals 2 to the x, so that means that the domain will be 0 to infinity, and the range will be -infinity to infinity. And you didn't actually need this to figure out these two. The range will always be -infinity to infinity for the logarithm, but the domain is wherever the argument is greater than 0. So in this case, that means that x has to be greater than 0. And in interval notation, that's 0 to infinity. Okay, awesome. Let's go ahead and graph these. So I'm going to go ahead and graph the first one. The 3 key points were -1, 1/2, 0, 1, 1, 2. And we had a horizontal asymptote of y equals 0. Now there will be another point here, 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 here. Just to help me graph this a little bit better. Good deal. Now, that is the y equals 2 to the x function. The next thing I'm going to graph is the y equals log base 2 of x. So I'm going to graph it with a vertical asymptote of x equals 0. So it'd be 1, -1/2, 1, 0, 1/2, -1, my apologies. 1, 0, and 2, 1. And also I'll have another coordinate here, and here, and here, here, and so on and so forth. And this is just helping me graph correctly. Awesome. And this, of course, is y equals log base 2 of x. Now notice that this is just going to keep going down forever this way, getting closer and closer to the x equals 0 line. And just for laughs, let's go ahead and graph y equals x. There you go. That is y equals x. And notice that this is, in fact, symmetric about the line y equals x. Alrighty. Well, I believe that's it for this particular video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.